Hello students, welcome to Mechanical E-Learning. Today we'll be solving some numericals on Hooke's law and simple stress and strain. In the previous lectures, we have understood the concept of Hooke's law and found some of the formulas corresponding to Hooke's law. Now let's solve some numericals on Hooke's law and simple stress and strain. A load of 5 kilonewton, that means P is given, is to be raised with the help of a steel wire. Find the diameter of the steel wire if the stress not exceed to 100 megapascal. According to the given data, load is given as 5 kilonewton and stress is given as 100 megapascal. So 1 megapascal is equal to 1 Newton per mm square. So here 100 megapascal, that means it will be equal to 100 Newton per mm square. And P is given in kilonewton. So we have to convert it to the Newton. Okay. We have to find out the diameter. So for that, the stress formula, we know that is the load per unit area. That means P divided by area. Okay. So here P is known, sigma is known. So we can easily find out the area. Okay. So area will be P by sigma. Put the values now. We'll get 50 mm square. Okay. Next, it is a where, so area will be pi by 4 d square. Okay, pi by 4 d square was found out 50. Here, you can easily find out what will be the d square value. Then we'll take the root of it, and we'll get the diameter of the where. Okay, the next problem. A steel rod of 25 mm diameter. So here the diameter is given and 2 mm long. So length is given. Subjected to an axial pull of 45 kilonewton. Okay, so load is given here. Okay, axial pull is given. So that means it is there. It will generate the tensile stress. Okay, so find the intensity of stress. That means we have to find out the stress. Then we have to find out the strain. Then elongation. That is nothing but the change in plane. Okay, we have to assume Young's modulus as 2 into 10 to the 5 Newton per mm square. Okay, so let's first write down the given data. So according to the question, we have load, that means P equal to 45 kilonewton. Okay, Young's modulus is 2 into 10 to the 5 Newton per mm square. So force we have to convert it to the Newton. So 45 kilonewton, 45,000 Newton. Okay, diameter is given 25 mm and length is given 2 meter. Okay, so according to the formula, that is stress is equal to load per area. So load is given 45,000, diameter is given. Okay, so if the diameter is given, formula will be pi by 4 d square. So d nothing but 25. Put all the values, then you will get the stress value 91.65 Newton per mm square. Okay, stress we have calculated. Then comes to strain. Okay, so a formula, Hooke's law formula, that is Young's modulus is equal to stress divided by strain. Young's modulus is nothing but the ratio of stress to the strain. So from that equation, we can also get strain is equal to stress by Young's modulus. Okay, so here the stress is given, that is we have calculated 91.65. Young's modulus is given 2 into 10 to the power 5. Put all the values, then we will get the, then put all the values, we get the answer. Next, for the elongation. So we know that strain is nothing but change in length to the original length. Okay, so in that equation, you can see E is known or you have calculated already. L is given, that is, where is it? 2 meter long. So it can convert it to mm. And these two are given, so you can easily find out this value. That means DL is equal to epsilon, that means strain, into length. Okay, so you are getting the value of 0.916 mm. There is another formula of DL, that is change in length, which you have already learned during the lecture 1. So that is BL is equal to BL by AE. Okay. B is given, L is given, area you can find out like this, pi by 4 d square, and E is given. Okay. So put all the values and inform me if you are getting the same answer or not for the TF. Okay.